Welcome to the next video for Module 3B of MCT 450 Advanced Mechanics. In this video, we will review the different types of beam setups and their applications. A beam is any mechanical member that supports transverse loading. Beams may also experience end loading and twisting loads, also known as torsion, but end-loaded columns are a different matter and have their own failure modes and analysis methods. Beam setups may be cantilever, simply supported, overhung on one end or the other, or both, continuously supported, fixed ends, or propped cantilever. Take special note of the difference between a simply supported beam and a fixed beam. Remember, a simply supported beam is pinned at one end and can slide in the horizontal direction at the other end. A fixed beam means that both ends are fully constrained. Also note that cantilever and simply supported beams are statically determinate, meaning they can be solved via equilibrium equations. Fixed beams, along with overhung and continuous beams, are statically indeterminate and cannot be solved with equilibrium equations. Generally, we will use beam tables and charts in these instances. Beams come in a variety of cross-sections, each with their own properties and uses. Typical sections are T-bar, L-angle, square tube, round tube, channel, I-beams, trusses, and others. And with the exception of trusses, perhaps, each of these cross-sections have their own moment of inertia equations. Beams can have four different types of stress loading. The three primary ones are bending stress, direct shear stress, and torsional stress. End loading is a fourth possible stress, but less common in typical mechanical structures. Remember, when you have a transversely loaded beam, both bending stress and shear stress are present. Torsional stress only occurs if there's an offset load that is resulting in twisting of the beam. Let's review simply supported beams again in a bit more detail. Simply supported beams typically rest on two supports, and thus we have two reactions. One support is pinned, and the other is a sliding roller. We will look at some examples where expanding joints are often used in construction to provide the freedom to slide in the end direction, thus creating a simply supported beam. Also recall that in any 3D system, there are 6 degrees of freedom. 3 degrees of freedom are translational, meaning the object can slide in either the X, Y, or Z axis. The other 3 degrees of freedom are rotational, meaning the object can rotate either about the X, about the Y, or about the Z. A simply supported beam constrains 4 degrees of freedom. Notice the image of a simply supported beam in 3D space. Due to the pin constraint, the beam cannot rotate about either the X nor the Y axis. It also cannot translate in the Y or the Z axis, but it can rotate about the Z axis, and it can translate at one end in the X axis. In contrast, the fixed beam support cannot translate or rotate about any axes. It is constrained in all 6 degrees of freedom. Here are some examples of simply supported beams used in construction. Note the image with the spring device that allows for the X translation of the beam. This reference has been provided to you on my courses. It is much more extensive than the beam tables in the textbook. If you have not already done so, make sure you have downloaded the reference. I recommend that you pause the video and look through the information that is provided in the reference. Familiarize yourself with the types of beam supports and loading that are referenced. Note the differences between the distributed and concentrated loads. Note that most of the tables provide you with the reaction forces, the maximum shear forces, the maximum bending moment, and the maximum deflection for each type of beam setup. Plan to use this reference to check your work on homework and exams. This reference has also been provided on my courses. It includes additional beam setups that are not in the first reference. If you have not already done so, make sure you have downloaded the reference. Look through the information that is provided in this reference. Familiarize yourself with the types of beams and supports and loading that are referenced in this manual. That's it for this video. Thanks for watching.